Chapter 11 is areas and volumes of solid figures. So if you say, well, the area of a solid figure, how does that work? We would be dealing with surface area, okay? So surface area and volume of solid figures. Now, we're going to deal with prisms and cylinders first, then spheres, then pyramids and cones, and then we're going to look at the ratios of perimeters, areas, and volumes, which is like page 174A in my Algebra 1 text. We'll then have odd answer solutions for Chapter 11 and the Chapter 11 study guide. So here we go to Unit 11.1. Unit 11.1. Right, prisms and cylinders. Now, I'm not going to name all these pieces over here. You can look in your student edition for that. I'm just going to talk about that just a little bit. We call a corner a vertex. Plural for vertex is vertice. Vertices, okay? So B is a vertex, C is a vertex, point D is a vertex, point A is a vertex, point G is a vertex, point F is a vertex, point E is a vertex, and point H is a vertex. Now, a prism has a top and bottom that are congruent. Now, you have to draw this kind of whomper-jawed looking just so it will appear when you're done to be a square. A pyramid comes up to a point. A prism has a congruent top and bottom. A right prism, a right prism is such that that angle at F going up, angle CFE is 90, so it goes straight up. It doesn't lean. If your prism was leaning, it would be an oblique prism, okay? So a prism has a congruent top and bottom. All of the corners we call vertices. All of the segments we call edges. So when you think vertice, you may be thinking corner. When you think about edge, you're thinking segment. So how many edges? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. The green things are the bases, the upper base and lower base. They're also called faces, but they're special kinds of faces, which we call bases. The edges at the base are called base edges. So AB, BC, CD, AD, HE, EF. I don't see the point back there. GF. The blue segments that are touching the green are called base edges. These going up and down are called lateral edges. Now, lateral means side, so the edges on the side, okay? So we have the edges on the bottom and top. The edges at the base are called base edges. The edges around the sides are called lateral edges. A flat surface, which would be like a plane, is called a face. The red going around the side are called lateral faces because it's the faces that make the sides. And the green was called the bases, okay? All right, so there's the parts of a polygon. Vertices, edges, faces, lateral edges, base edges, lateral faces, and bases. Okay, and you can study all of that. Formulas. Formulas for lateral area. Now, we have webs today that's on a lot of our standardized testing, and I'm not a big web fan, but if we want the lateral area, let me show you what we're going to do. If we want the lateral area, we just want the sides, and so what you would do is you would want to take this and that back side, left side, and that back side, and that right side, and you would want to find all of those. So we're leaving off the top and bottom. Now, if we cut this with a pair of scissors and we folded it out, then what we would have is 4 congruent rectangles. That would be the front. We keep folding, and that would be the left, and that would be the back, and that would be the right. And when we got done, it would fold into one big long rectangle, those sides. The area of a rectangle is whatever the base is times the height. The base of that folded out rectangle is going to be the perimeter of the base. So the formula for the lateral area, the area of all the sides, not including the top and bottom, is the perimeter of the bottom times the height of the prism. Lateral area, perimeter of bottom times height of prism. If you want the total area, you have to add the area of the top and bottom to that. Now the top and bottom are congruent. So we can say 2 times area of bottom. And that'll give us the top and bottom plus our lateral area, which is that, and we have the total area. So total area, 2 times area of the bottom plus perimeter of bottom times height. Now when we're thinking volume, we're thinking 3 dimensions, and the first 2 dimensions would be the area of the bottom. Now, on some formulas charts, they'll call the area of the bottom big B. And then it's like we need a whole bunch of those stacked on top of each other. And so we're going to fill that thing up. Okay, so let me try to do a little bit better job of that. It's like you would have a ton of these little flat surfaces, a ton of these areas, stacking up, stacking up, stacking up. You'd put one here, 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 and you would stack those until you got all the way to the top, and you'd fill that up. So the formula for the volume of a prism is the area of the bottom times the height. The area of the bottom times the height, or big BH, as it says in some formulas charts. So the area of the bottom times the height of the prism. Everybody see how we came up with those formulas? So we want these formulas to mean something. We want you to be able to understand them. The area of the sides, lateral area. If you fold out the sides, you get a big long rectangle whose base is the perimeter and whose height is the height. So lateral area, perimeter of bottom times height of prism. Total area, well, you add the top and bottom to that. So 2 times the area of the bottom plus the lateral area. Volume, what do? Well, you start pouring stuff in, it fills up the bottom, and then it starts filling up. And if you visualize, you fill it up, you're getting what filled the bottom up over and over and over and over and over, which is the height. So you're visualizing a stack of bases that go the height tall. So volume is area of the base times the height. Area of the bottom of the figure times the height of the prism, okay? All right, so there's our formulas, and let's make application here. We want the lateral area, total area, and volume of this triangular prism. So, lateral area is perimeter of bottom times height of prism. Perimeter of bottom times height of prism. The bottom and top are congruent. The perimeter is the sum of the sides. 14 plus 10 plus 12. The 9 is the height of the triangle. 9's the dotted line. So 14 millimeters plus 12, 10 millimeters plus 12 millimeters. I may need a little more space. Perimeter of bottom, 14 millimeters plus 10 millimeters plus 12 millimeters times the height of the prism, 18 millimeters. We're going to do what's in this parenthesis before we multiply. So 14 plus 10 is 24 plus 12 is 36 millimeters times 18 millimeters. When you multiply the numbers and you multiply the names and you get a new name. And when you multiply with like bases, you add the exponents. So we get square millimeters. And we have 36 times 18, and I'm going to hit the calculator here. 36 times 18. 648. So the lateral area is 648 square millimeters. 648 square millimeters, and we weren't asked to convert. So what about total area? Well, total area is 2 times the area of the bottom plus the lateral area, which is 648 square millimeters. The bottom is a triangle. The area of a triangle is 1/2 times base times height. The base of that triangle is that side we knew, 14, that had a height drawn to it. So we're going to have base 14 and height 9. So the area of the triangle is 1/2 its base times height. So 1/2 times the base, 14 millimeters, times the height, 9 millimeters. To solve, we're going to do what's in the parenthesis first. Half of 14 is 7, times 9 is 63. Millimeter times millimeter is square millimeter, plus 648 square millimeter. We're going to multiply before we add. So total area equal 2 times 63 is 126. Name tags along, square millimeter, plus 648 square millimeter. Now we're going to add, the name is the same, square millimeter. So we get total area equal 774 square millimeter. So we found the lateral area by taking perimeter of the bottom, which was the same as the top, times the height of the prism. Then to get the total area, we added the bottom and top to that. So we went 2 times the area of the bottom plus the lateral area, which gave us the total surface area. Okay. Now, I'm going to clean some of that out just so I can find volume. Volume is area of bottom times height of prism. And the area of the bottom again was 1/2 times its base 14 millimeter times its height 9 millimeter. So we take area of the bottom and then we fill it up by multiplying by the height. Now this is all multiplication. So we're going to go 1/2 times 14 times 18 times 9, or 1/2 times 14 times 9 times 18. And then we're going to have millimeter times millimeter times millimeter. When you multiply with like bases, you add the exponents, and so we get cubic millimeters, which we would expect for volume. So we need to do that multiplication. 1/2 times 14 times 9 times 18. 1/2 14, 9. I lost it, sorry. 9. 1/2 14, 9, 18. 1/2 14, 9, 18. 1334. So the volume is 1,334 square millimeters. Now, I did show you down there how to convert to centimeters. Let's go ahead and talk about that with the volume, because we've mainly dealt with perimeter and area and we haven't dealt with volume. So let's do a conversion in volume. Let's say we wanted that in cubic centimeters. So we would have 1,334 cubic millimeters. We would want to lose that name cubic millimeters and gain the name cubic centimeters. A cubic centimeter is a cc. You may have heard of that. When you're giving an animal a shot, you get so many cc's of this or that. Okay. Centimeters the big one, millimeters the little one. There's 10 milli in a centi, but we're not dealing with centi milli. We're dealing with cubic centi, cubic milli, so we cube the conversion. Volume is cubic units. 3 dimensions. So 1 cubed is 1, 10 cubed is 10 times 10 times 10, which is 1,000. We're losing the name cubic millimeter. When you divide by 1,000, it moves the decimal 3 places, so we would have 1.334 cubic centimeters for volume if we changed it into cubic centimeters. Okay? About the size of a sugar cube, if you're familiar with that, or it's a little over 1 cc of an injection if you're giving an animal a vaccination or something. Okay? All right. So let's look at the daily work. In the examples, we had a square prism. We did some work with a uh, triangular prism. So in the homework, why don't we work with a circular prism, which is also known as a cylinder. Okay, so we're going to use our formulas here. For lateral area, remember that lateral area is equal to the perimeter of the bottom times the height of the prism. Now, the perimeter for a circle is called circumference, and circumference is 2 pi r. So it's kind of like we're going to cut that right there, and we're going to fold the sides of that out, and we're going to make a big long rectangle. The length of that rectangle when you fold it out is the circumference of the circle. Circumference is 2 times pi, which is 3.14, times the radius, which is 8 centimeters. So we have the circumference. That's the sides folded out, so that would be the base of the folded out rectangle, times the height of the prism, 20 centimeters, the height of the folded out rectangle of the sides, and then we can multiply to find the area. So we can just multiply everything because it's all multiplication. 2 times pi times 8 times 20. So we'll just do that on the calculator. 2 times 8 is 16. 16 times 20 is 320. 320 pi. So 320 times 3.14. 1,004.8. That's multiplying the numbers, and you multiply the names and you get a new name, and when you multiply with like bases, you add the exponents. So the lateral area is 1,004.8 square centimeters. It says put the answer in millimeters. We'll do our converting in a moment. Let's go ahead and find total area. To find the total area, you're going to add the top and bottom to that. So we're going to say 2 times the area of the bottom. The bottom is a circle. The formula for every circle is pi, which is 3.14, times the radius, which is 8 centimeter quantity squared. So we get 2 times the area of the bottom, which gives us the top and bottom, and then plus the sides, which was that 1,004.8 square centimeters. So we're going to have 2 times pi times 8 square. 2 times pi times 8 square. We need to do the 8 square. 2 times pi times 8 square. 401.92. Centimeters square, plus the sides, 1,004.8 square centimeters. So that 401.92 is the top and bottom. The 1,004.8 is the sides. Top and bottom plus sides gives you total surface area. And that bunch of red stuff means is an addition, add. So we're going to add those. And so we're going to have total area equal 1,004.8 added to that. And we get 140672. 140672. square centimeters. So I'm going to write these down so I don't forget. This is 1004.8 square centimeters, and this was 1406.72 square centimeters. It wanted the answers in square millimeters, so we need to convert. I just didn't want to forget them, and I wanted to hang on to my lateral area to help me find my total area, and then I'm going to convert them both together. Okay, so now let's convert our lateral area. 1004.8 square centimeters. We need to lose the name square centimeters and gain the name square millimeters. The bigger one is the centi. There's 10 milli in a centi, but it's not centi and milli. It's square centi, square milli. So we square the conversion and get 100 to 1. The name square centi is canceling. 100 times that would shift the decimal 2 places right. And so we would have 1004, move the decimal 2 more, 80, square millimeters. 100,480 square millimeters. Now, the other one is area also, so it's going to get multiplied by 100 also. So the decimal would shift to the right 2 places also. So we'd have 140672, 140,672 square millimeters. Okay? And now we'll work with volume. The volume is the area of the bottom times the height. Area of the bottom times the height. The bottom is a circle, and the formula for every circle is 2 times pi. I'm sorry. The formula for area of a circle is pi times radius square. I think I just as well start over. Let me hit it with white out again and take off again. And so volume is area of bottom times height. The bottom is a circle. The formula for a circle is pi times the radius, which is 8 centimeters quantity square. So we have area of the bottom. That's like having this. And then we're going to fill it up, multiply by the height, 20 centimeters. Okay? And so we're going to have volume is, we're going to have to square the 8 and square the centimeters because that distributes. So we're going to have 3.14 times 8 squared times 20. 3.14 times 8 squared times 20. 4,019.2. 4,019.2. And then the names, we're going to have centimeter square times centimeter to the first. When you multiply with like bases, you add centimeters to the second times centimeters to the first would be centimeters to the third, or cubic centimeters. And there's our volume in cubic centimeters. cubic. But it didn't want the answer in cubic centimeters. It wanted the answer in cubic millimeters. And so we're going to start with the 4,019.2 cubic centimeters over 1. We're going to multiply such that we lose the name cubic centimeters and gain the name cubic millimeters. The larger of the two is centi, so we have one of those. The smaller is milli, so we have 10 of those. But we're not dealing with centi milli. We're dealing with cubic centi, cubic milli, so we cube our conversions. 1 cubed is 1. 10 cubed is 10 times 10, which is 100 times another 10, which is 1,000. So we're multiplying by 1,000, which moves our decimal 3 places. So we would have 4019. Our decimal moves 3 more, 200. 4,019,200 cubic millimeters. Any questions on 7, 8, and 9? Okay, so that was a look at volumes of prisms. This particular type of prism is a circular prism, and it's better known as a cylinder. Okay, we've got some more on the next page. We might do well to practice one of those. We've got the regular hexagonal prism, and we have a trapezoidal prism, a trapezium prism, and then we have another cylinder. Maybe it would do good for us to deal with the trapezoid. We've done a good bit of regular hexagon stuff as we dealt with the regular polygons, so you're going to need to remember your regular polygon formulas there and how to get the interior angle, and then know that the apothem bisects a side and the radius bisects an angle, so you're going to get all these special triangles. Remember all that from the regular polygon section of chapter 10. All right, let's go to the trapezoid. I find that I have students at times that are concerned about trapezoid stuff. Just we don't use them a lot. Lateral area. Now, to find the lateral area, we're thinking about all the sides. So it's like we're going to cut that, and we're going to fold all these sides out until we get all the way around and back to here. And so we're folding all of those sides of this thing out into one big long rectangle. And to find the area of a rectangle, you take base times height. The base of that folded out rectangle would be the perimeter of the bottom, and the height of that folded out rectangle would be the height of the prism. So we need the perimeter of the bottom times the height of the prism. Now, to get the perimeter of the bottom, we have 4, 5, 6, and we don't know. So we have 4 plus 5 plus 6 plus, we don't know that one. Perimeter of the bottom times 8. Well, how are we going to get that? Well, let's extract that. This is 5. This is 4. This is 6. The 4 was dotted. I'll go ahead and dot it. It's 3 as far as an altitude, but it's not doing us a whole lot of good where it's at. We're going to scoot that 3 over here, draw an altitude from here. We're going to put another one like it here. If it's 3 straight down, it's 3 straight down anywhere. And what that does is it gives us a rectangle so opposite sides are equal. That takes us from dot to dot. And so what we need is those other two pieces. I'm just going to call this little piece X, and I'm going to call that little piece Y. In the triangle on the left, we can do a C square equal A square plus B square to find X. In the triangle on the right, I can do a C square equal A square plus B square to find Y. Okay? So I'm going to get C, which is 4 square, equal A, which is X square, plus B, which is 3 square. So I'm going to have 16 is equal to X squared plus 9. I'm going to subtract 9. And I'm going to get X squared equal 7. Take the square root. And so X equals square root 7. Okay? X equal square root 7. All right. Well, that's what you would have done. I should have looked at my teacher's edition. This transparency has a piece that didn't run off very well, and I apologize for that. This is not quite that complex. I thought, boy, I'd had fun with this one, didn't I? Well, had I not given you that opposite side was 11, you can see pieces of the 11 still remaining there. We could have done some crazy stuff and gotten it. Now, if you do all that crazy stuff and you don't get 11, then it's because I wasn't expecting you to do all that crazy stuff. So I guess there's the possibility that that wouldn't come out. Anyway, forget that. This was 11, which somehow didn't print off on my transparency there. So we can find the lateral area. The lateral area is equal to, we're going to add those up. 4 plus 5 is 9, plus 6 is 15, plus 11 is 26, times 8. So the lateral area is 26 times 8, which is 208. We didn't have units of measure to deal with. And there's no need to even think about rounding to the nearest 10,000th because we got pretty numbers. The total area, to find the total area, you would add the bottom and top. So you would go 2 times the area of the bottom plus the lateral area. Now, the bottom is a trapezoid. And the formula for a trapezoid is 1/2 height times sum of bases. So we're going to have 2 times the area of the bottom, again, which is 1/2 times the height. The height of the trapezoid is the 3 times the sum of the bases, upper base 5, lower base 11. So that gives us 2 times the area of the bottom, which is 1/2 the height times the sum of the bases, and then we would add to that our lateral area that we've already calculated, which is 208. So we're going to do 5 times 11 is 16. 2 halves is 1 whole. 1 whole times 3 is 3. 3 times 16 is 48. 48 plus 208 is 256. Okay? Volume. Volume is area of bottom times height. Area of bottom times height. It's like you find the area of that base, and then you fill it up. Some books, some formulas charts call it big BH, area of bottom times height. I think it's easier to just say area of bottom, then you know what you're talking about. Anyway, the volume is the area of the bottom. The bottom is a trapezoid. The formula for every trapezoid is 1/2 times the height, which was the 3, times the sum of the bases, which were the 5 and 11. So there's the area of the bottom, and then times the height of the prism, 8. So 5 plus 11 is 16. Half of 16 is 8. Times 8 is 64. 64 times 3, 192 for volume. Any questions there? Okay. And then we have another cylinder. We have some word problems here, and I want you to have to deal with these, so I'm going to let you work on these. Number 919 is an odd one. You can kind of check that in the back. On number 20, this is not necessarily the dimensions of a gallon bucket, so don't take this literally, but we're just going to use this as to solve with. So we're assuming here that a gallon bucket is 3.5 inches by 9 inches. Could have measured, and then we want to find out how many of these will go into there. Okay. All right, so that's 11-1.